Hi viewers, this is Sri Ramulu. Before watching this video, please subscribe it and don't forget sharing and liking. Let me enter into the topic. So, our today's topic is phase velocity. So, what is the phase velocity? See the definition. Phase, the velocity with which planes of constant phase advances through the medium is called phase velocity or wave velocity. See here, planes of constant phase. For example, one wave is traveling with constant phase. Constant phase means their phase difference must be same, right? How many planes are traveling, how many planes are moving, for all the planes their phase difference must to be same, means that is a constant. And if they travel through the medium, then that is called phase, then the velocity of that wave is called phase velocity or wave velocity. So this is a phase velocity or wave velocity, and its formula is Vp is equals to omega by k. Vp, P indicates phase, V indicates velocity, omega angular frequency, and k is a propagation constant. And now consider a monochromatic wave whose displacement y is expressed as, here constant phase, not only constant phase, it must be a monochromatic wave. Then only the velocity of that wave we called wave velocity or phase velocity. And right, and now see the displacement y is equals to sin omega t minus kx. And where a is, the small a is what? Amplitude, omega's angular frequency can be written as 2 pi nu, and propagation constant k can be written as 2 pi by lambda is the propagation constant of the wave, right? The next, for the wave, just now above what equation I have written. So just now I have written y is equals to a sin omega t minus kx I wrote. For this is a omega t minus kx is constant. Why? Because phase difference is constant. So that means this phase, this angle must be constant, right? For this constant, see here, that is a constant is written. And differentiating the equation 1 with respect to the time we have, that means whatever things we have said as constant, let that is equation 1, and differentiate that with respect to time we have to differentiate. Then see here, omega t minus kx is equals to constant, means differentiating what you get, differentiating with respect to time. So here time value is 1. Why? Because we are differentiating with time. Then omega minus, here kx, k is constant, k constant, x is can be written as dx by dt is equals to constant, differentiation is 0 right? And see here, this dx is the distance by time. Distance by time can be written as velocity. That velocity is what? Phase velocity. Okay, now see, let me erase this one, right? And see here, this is a minus term is there, bring that is the other side, then omega can be written as minus k dx is here what? Vp. Why? Velocity, distance by time is velocity. Vp is equals, and it is not minus. Why? Because already we brought it outside, equal, that should have the equal, then it becomes plus, and bring k this side, omega by k is equals to Vp. So that is the same thing we got. Like this we have to derive this one. And next, group velocity. So for phase velocity we have taken monochromatic light. In group velocity we take group of waves with a different amplitude, different frequencies, different wavelengths. So those things we take, and here let me explain the definitions here. The velocity with which the group of waves propagate through the space is called, through the space or through the medium is called group velocity, or we can define like this also. The velocity with which the energy in the group is transmitted is called group velocity. Like this also we define them. Therefore group velocity can be written as see, group velocity equation formula is Vg, group velocity d omega by dt, sorry dk. So differentiating wave velocity, then we get group velocity. See, that is simple thing. And see here, just wait please. Okay, and now see, consider the pulses rather than monochromatic wave. So what we have to consider? Pulses we have to consider rather than monochromatic, means without monochromatic we have to take different waves with different amplitudes, different frequencies. That is the meaning of pulses, right? So we have to take pulses. The pulse consists of number of waves slightly differing in frequency from one another, and the superposition means when the different waves they superimpose, means when they mix, when they interfere, that is superposition meaning of such wave is known as wave group. So that is a group of wave, right? Group of wave. Okay, so when they mix, then they form group of wave. So here in the definitions see, group is transmitted, or see here also group of waves also we said. So their velocity is a group velocity. Okay, next page. When such a group travels in the medium, the phase velocities of different components are different. Their velocities are different for the different waves. Okay, however the observed velocity is the velocity with which the maximum amplitude of the group advances is called group velocity. Maximum. What happens? Some of them what in superimpose, and they may form the interference. They form constructive interference and destructive interference. Sometimes intensity or amplitude increases and amplitude decreases. Okay. So the group of all the waves is what group velocity we call simply, right? The next, wave pocket. See the wave pocket. Right? Wave pocket. What is the wave pocket? See, wave pocket definition. A wave pocket compresses means compresses a group of waves. It consists means it contains, a wave pocket contains group of waves, that is the meaning. Group of waves slightly differing in velocities, means different waves may travel with the different velocities, and slightly differing in not only velocity and also wavelength also, their wavelength also slightly different. With the phase also different, amplitude also different, such that they interfere constructively over a small region of space. And see, they interfere means that is when the different waves when they superimpose, means when they mix, that is interfere. Okay, constructively over a small region, in the small region of the space where the particle can be located. Okay, suppose you are saying the particle is here, there what is happening there? all the waves are what having mixing means all the wavelengths are interfering. Okay, and outside of this space, outside of this space what, they interfere destructively, so the amplitude reduces to zero, and this is called wave pocket. See here, let me explain in details what they are saying. Let it is a small region, okay, and in this region what it contains, comprises means contains a wave group of waves slightly differing in velocity, wavelength, phase and amplitude. See, so they may have like this, its amplitude is here, this side is small and this side is also small, and in the middle amplitude is more, and it is one way I am showing, but it contains many waves, many waves. Then among them what happens, inside, only inside of this small region, few waves interfere constructively and few waves interfere destructively. What is the meaning of constructive and destructive? See here, constructive and destructive. Constructive means, for example, it is a one wave and this is another wave, and it is crest for this wave, and for this wave it is a trough and it is a trough. When crest and crest interfere, then they form maximum amplitude. See, its amplitude is this much only. When these two waves interfere like this, crest to crest, then they form maximum amplitude, and when the trough and trough interfere, then they form maximum amplitude trough. So like this type of interference is called what? Constructive interference. Okay, next, destructive interference. See here, destructive. Suppose it is a one wave and another wave is like this. When crest of one wave and trough of another wave interfere, then what happens? Then it is a positive and it is negative. So then positive, negative, when those two things interfere, then they cannot form any crest or trough, right? So here one crest to one trough, when they mix, then amplitude what happens? Decreases and reaches to zero. So zero amplitude means no wave is formed in this case, because it is destructive interference. Destructive interference means crest of one wave, trough of another wave. When these two things interfere, then no amplitude forms. So amplitude, there is no amplitude means their amplitude what happens? Decreases. So we may say it is reduces to zero also. Okay, and this thing where it happens, you know, if it is a wave pocket, it is a wave pocket. Suppose at this point, let it is a one point, means that is a particle, and inside this wave pocket constructive interference occur, and outside of this wave pocket destructive interference occur. Why? Because inside here we are observing here the wave means there is a constructive interference, but there is no outside any wave, so that is a destructive interference. So that is the thing. Okay, and next, and see, according to de Broglie concept, matter has dual nature. That is, sometime it behaves like a particle and at other time behaves like a wave. Yes, that is already I explained you in the de Broglie concept. Okay, in the de Broglie hypothesis. Next point is according to Schrodinger. It is according to de Broglie. It is according to Schrodinger. According to Schrodinger, a wave pocket most with a own velocity called the group. Sorry, it is a mistake. Okay, it is most with own velocity, the group velocity, the individual waves are forming the wave pocket have, it is no nothing, have an average velocity which is called phase velocity. Okay, individual. So here it is one wave. It's one way. It is one wave. Its own velocity is what? Phase velocity or wave velocity. Let another wave is there inside. That with that's velocity also phase velocity or own velocity. But this velocity and this velocity may not be same. So their velocity may be different. Why? Because it is a wave pocket. Inside the wave pocket, different waves may have the different velocities. Okay, its phase is one. It may contain one type of phase difference, and it may contain another phase difference. Okay, for this it is constant, and for this is constant. Why? Because while traveling this wave, its phase may not change. Its phase also may not change, and its phase, let it is a 70 degree, and its phase may be 80 degrees. So while it is traveling this wave, continues the same phase, and while it is traveling this wave, it may continue this phase same. But if you compare these two things, then the phase differences are different. For this no changes. For this no changes. Like this, it contains, this pocket may contains many waves inside it. Inside it, only one wave is shown. Okay, inside it, and it travels. So that is why it is a group velocity. Okay, so like this, it is a wave pocket diagram. Okay, thank you friends for watching this video. So once again, please subscribe it. Don't forget subscribing, and share it to your friends. Okay, thank you friends.